Hello everyone. Thank you for joining us for our webinar today. Before we get started with the presentation, let me introduce myself and also give a little brief about our company. So, I'm Janish and I'm the Product Marketing Manager of AppViewX. AppViewX is a global leader in the management, automation and orchestration of network services, be it ADCs, firewalls, digital certificates, and SSH keys in brownfield and greenfield data centers. We have 5 products on our platform. There is ADC Plus that manages and automates ADC devices, CERT Plus that manages and automates digital certificates, SSH Plus that manages and automates SSH keys, and Security Plus that manages and automates firewall devices. On top of it all, Automation Plus that manages and automates network service requests. All of our products support hybrid deployments, as in supports devices that are installed on premises and in the cloud. I'm the product marketing manager of CERT Plus, SSH Plus, and Security Plus. I'll be your presenter for today. So, enough with the introductions, and let us talk about why we are actually here. How to avoid being a victim of private key based attacks. So, before jumping on to the presentation, let us look at what are these private keys. Private keys form one of two keys generated in a public key infrastructure, or in short, PKI. This key must be kept confidential by its respective owner, while the public key, one of the other keys that is generated, is made available to everyone. Digital certificates also take a similar approach. First, you generate a key pair, a private and a public key. After that, a certificate signing request is generated which holds all your details like your organization name, FQDN, the fully qualified domain name, and also your public key. This CSR is then signed with your private key to prevent others from receiving a certificate under your name. Finally, the CSR is sent to the certificate authority for receiving the certificate. Since private keys are your identity in a PKI, we do not want malicious actors to get hold of your identity in extension to your private key. But is it even possible in the current scenario? Let us look. The growing use of PKI. Encryption is a good thing. Thanks to the efforts taken by browsers such as Google Chrome and Mozilla Firefox, HTTPS adoption has seen a 30% growth since 2016. The strong foundation of PKI has helped the use of digital certificates in other applications such as client or user certificates, S-MIME certificates that are used to sign emails, code signing certificates that are used to sign your application codes or even documents, mobile device certificates that are used to authenticate your mobile devices, and now IoT, the Internet of Things devices. What's next? With these growing applications, we have also just increased the attack surface for hackers. There are lots more digital certificates that need to be protected so that hackers don't get access to these digital certificates. So let us also look at the growing misuse of these digital certificates or PKI. Hackers are behind these certificates for its cover, the encryption and trust it provides. With the advent of Stuxnet in the year 2007, which was the digitally signed malware that was used to foil the attempts of Iran's nuclear dominance. This attack particularly used digital certificates to evade detection, and ever since, similar attacks have been on the rise. In fact, in 2012, more than 200,000 unique malware binaries were signed by valid digital signatures that were either stolen or forged. This number almost tripled in the year 2013 and has been increasing ever since. Few other attacks that are of prominence are the attacks on digital certificates like the Komodo and DigiNotar to compromise their private keys in the year 2011. Hackers used their private keys that were stolen from these certificate authority and resulted in the fraudulent issuing of certificates. In 2014, a severe bug in OpenSSL software that is used to generate key pairs was gave rise to Heartbleed that infested more than 70% of the internet. And in 2016, Carbanet was used to compromise data worth 1 billion USD with the help of valid and revoked certificates to major certificate authorities. So, be it stealing your data or your customers' data, why are all these attacks so successful? It is because your private key or digital certificate stands for your customer's trust online. Hackers steal your identity by stealing these digital certificates and cause an extensive damage to your brand reputation. Even with various advancements in security measures over the years, enterprises still fail to identify a malicious encrypted traffic accurately. So, is it time we look beyond traditional methods that block an attack and focus on methods that will actually deem the valuable data, such as the private keys that are being stolen by these hackers, useless? Before we proceed further, let us step back for a moment and look at how a sample cyber attack is being orchestrated by a skilled hacker. First, let us examine the hacker payload. This can comprise of an exploit kit, which can run on web servers to exploit vulnerabilities in the client's machine, or a Trojan horse, which can be disguised as a legitimate software and made to compromise valuable data, or a rootkit, which can enable administrative level access on a network, or an adware, which can use hidden malicious codes that execute on clicking an ad on websites, or a man-in-the-middle attack, which can hijack a session between two machines using various vulnerabilities in the protocol on use. Or a hacker can also use a combination of all these attacks. But how do they deliver this payload to their target? Through phishing emails that are sent to unsuspecting employees, through insiders who may be a current or even a former employee gone rogue, and through malicious websites designed to imitate legitimate websites using fake or stolen digital certificates. Once the payload enters the enterprise PC, they can use one of the various vulnerabilities inside an enterprise PC, such as an outdated PLC or an outdated Skype, a protocol level vulnerability in Chrome, an outdated Flash, and even an outdated operating system such as Windows, with the most famous example being the WannaCry ransomware that infected more than 300,000 computers worldwide by using a vulnerability in the Windows operating system. Once the vulnerability is exploited, the hacker gains access to valuable data such as user credentials, the private keys of a certificate, and SSH keys. From there, they pivot to other systems. How do they pivot? If the stolen keys give access to other systems in the network, they can use those stolen keys, pivot to other systems, and spread the infection. So how do we stop this? One effective way will be to stop the hacker even before he reaches the network. But with software vulnerabilities such as the outdated VLC or Skype that we have talked about, creeping every now and then, this is almost impossible. One other effective way will be to make the compromised private key data unusable. How do we make them unusable or useless? How can private keys in infrastructure be protected? There are three ways. Limiting the storage of private keys to a few computers and restricting access to these computers. How do we restrict access? By using your directory systems, such as an Active Directory or an LDAP to restrict user access. Though this is effective, this is least recommended for various reasons. Encrypting the private key and storing it in a password protected folder is also another effective method. This leaves the hacker to first brute force the password and then decrypt the private key, by when your enterprise can identify the breach and all the private key content in your enterprise can be changed. This particular method is effective but leaves much to be desired when you need to scale it, as in you need to encrypt every private key and also remember the password of each folder where the private keys are being stored. So what will be the next method? Storing the private key in a secured location such as an SSM. An SSM or a hardware security module is a device that safeguards and manages valuable data in an infrastructure, either by encrypting them or making them impossible to be retrieved. This method is highly recommended in terms of scalability and also its level of security. And if you are serious about the safety of your private keys, it is time you invested in an HSM. So, how does an HSM safeguard your private keys? We can essentially take two approaches. Option 1. Use HSM for just encrypting your private keys. We can have a master encryption key inside the HSM and use it to encrypt the private key. If you want to go a step further, you can introduce multiple layers of encryption by including a key encryption key and a data encryption key in the mix. Once the private key is secured, the certificates can be procured from the respective certificate authorities and pushed to the respective devices. Let's talk about option 2. In option 2, we can secure the private key inside the HSM and just use the private key reference to push certificates to the required devices. This makes it almost impossible to retrieve or delete the private key inside the HSM. What do you think about these two approaches? Are they complex? Are they difficult? Yes, we agree. It is complex if, and that is a big if, it is done using manual methods such as spreadsheets. And herein comes the challenge. 85% of enterprises today manage their digital certificates through spreadsheets or handwritten notes, which is an incapable and inefficient certificate management system. Why? Apart from just making it difficult to protect your private keys, there are a couple of other drawbacks too, which are less visibility across certificates. Why is visibility important? Let us take the example of a recent event, the SHA-1 to SHA-2 migration. All certificates with SHA-1 signature were being deprecated by browsers and were needed to be migrated before the browser deadlines. Since the probability of introducing undocumented or rogue certificates with the manual management are higher, what if you did not migrate all SHA-1 certificates before the deadline? Browser warnings and the threat of a security breach would have seriously impacted your business, leaving visibility a very important parameter in the certificate management system. Lack of proper policy enforcement, such as using only recommended certificate authorities and not certificates from free certificate authorities such as less independent, and also controlling access to these certificates, as in who has access to what certificates and what servers. Poor control over private keys, unsecured storage and distribution is one of the most important things that is being plaguing the manual management of digital certificates. In addition to this, there are certain other risks associated with the manual management that can cost your enterprise dearly. That is, if you do not properly document each certificate in your infrastructure, the risk of an expired certificate bringing down your application is higher. So, with all these drawbacks of manual management, is there a better solution? Yes, automation. By automating each component in your certificate lifecycle system, from generating key pairs to issuing certificates and renewing these certificates, you essentially reduce the complexity and also the possibility of costly human errors in each step. Apart from this, an automated system also simplifies the protection of your private keys, making this a very invaluable addition to your security posture. And with this, Gartner also recommends the use of a certificate lifecycle management solution when the number of certificates in any infrastructure exceeds 200 to mitigate a variety of risks that were discussed in the previous slide, in the challenge slide. With this, we introduce our product, AppViewX CERT Plus. AppViewX CERT Plus is a single-stop solution for digital certificate and key lifecycle automation. Every possible step in the lifecycle is automated, from certificate discovery to certificate provisioning and certificate verification. AppViewX CERT Plus also gives a holistic view of all certificates in the environment with intuitive single-click actions. Certificate discovery and inventory. Let's talk more about certificate discovery. Discover digital certificates across various servers, clients, and ADC devices using a mode of your choice, be it IP range, subnet, or URL. The Discover certificate and its private keys are automatically imported into a 256-bit encrypted database, or if you want to go a step further, you can store these private keys inside an SSM. These certificates can be tracked using two modes. Manage mode. Manage mode allows the user to perform certain actions like push, renew, or rollback. And if you just want to limit the actions on a certificate and just want to monitor the expiry status or the validity status of the certificate, you can use the monitor mode. Let's talk more about how we protect private keys in your infrastructure. This is a sample diagram that depicts our integration with various devices. Using REST API gateways, we can easily integrate with external vendors. Once the SSM device details are configured on the platform, you can choose between storing the private keys inside a 256-bit AES encrypted AppViewX database or inside a network SSM. Either way, the CSR is sent from AppViewX and the corresponding certificate authority responds with a certificate, which is then pushed to the respective devices, shown here either to an ADC or a server. The various certificate authorities that we support are Komodo, DigiCert, Entrust, GlobalSign, GoDaddy, etc. Thus, to reiterate, AppViewX CERT Plus is a single-stop solution to provision, revoke, renew, and manage digital certificates and its private keys. You can view and also receive standard reports on certificate expiry, on certificate authority, also on certificate compliance. What does a certificate compliance mean? Each certificate in your infrastructure is validated against a set of policies and rules that are set by you, such as recommended certificate authorities, recommended cryptographic algorithms, and the corresponding non-compliant certificates are highlighted for further action. As said before, we can also monitor the expiry status of each certificate and renew certificates on time every time to prevent unnecessary application downtime. The holistic view represents the certificate chain of trust and its associated devices graphically with suitable certificate-related actions kept handy using a single click. We are integrated with all major certificate authorities such as Komodo, Entrust, DigiCert, etc., as already mentioned in the previous slide. We have also integrations with various ITSM systems such as ServiceNow to make your workflows seamless. So, with all these certificates in your infrastructure, how do you ensure accountability and delegate proper access to these certificates? With CERT Plus, Granular role-based access control, you can provide granular access to the certificates, its private keys, and various configuration templates. The configuration templates here are the various workflows possible on our platform, such as push, renew, and revoke. You can create, change, and discontinue roles as needed, or also use your directory services such as Active Directory, LDAP, or Radius to determine the level of access required for each role. Apart from bringing accountability, this also improves the operational efficiency and also boosts cross-team collaboration. The number of certificates in your enterprise is growing every year in line with the increasing use case. Can our product scale to meet your requirements? Yes. Our modular architecture can scale to support thousands of network devices. We also support horizontal scaling with multi-node deployments to meet heavy user and performance demands. To quickly support newer versions or products released by your vendors, we have got vendor plugins that can be independently released from the core platform. And we have two redundancy modes for any unforeseen circumstances, active active and active standby for any disaster recovery. Here's a customer who has implemented CERT Plus in their infrastructure. A world's leading media company has put close to 10,000 plus certificates on 700 multi-vendor devices from 4 CAs under management using CERT Plus. When this customer came to us with their requirements, these were the problems they were facing in their environment. Need to manually provision each certificate on devices with thousands of certificates that need to be pushed across multi-vendor devices. This was a complex task. We automated the provisioning of these certificates and drastically reduced the deployment time and increased resource utilization. Next, they had problems managing multiple certificate authorities. Four to be exact. They had to log into each certificate authority for requesting new certificates and also did not have centralized visibility across all these certificates. And with our help, they were able to deploy a vendor-agnostic platform to manage and automate certificates across multiple CAs without having to worry about mixed expiries and non-compliant certificates that impact uptime. Being a media company, uptime was a critical factor in ensuring seamless service to their customers. Without proper visibility across expiring certificates, they were suffering costly outages that seemed to impact their customer satisfaction. And with AppViewX Plus, they were able to renew each and every certificate on time, every time. So, to put these facts in terms of numbers, our customers were able to reduce up to 70% in issuance time. What is the issuance time? From generating CSR to receiving a certificate, and up to 83% reduction in deployment time, especially when dealing with multi-vendor devices in the infrastructure, and up to 70% reduction in validation time, as in validating the success of any PKI migration, such as SHA-1 to SHA-2 migration or any vendor migration. This is particularly important because this determines the success of any project. So how does AppViewX in the whole create value for your enterprise? By enabling you to move faster. How? By automating manual network infrastructure services such as protecting your private keys, enforcing compliance by helping you deliver and protect applications as intended. That is, we ensure there are no gaps in controlling access to the certificates or private keys and also ensure the certificates conform to your policies, eliminating costly errors. By removing error-prone manual steps such as certificate misconfiguration or losing private keys in development and production, reducing cost. By simplifying your network infrastructure and enabling you to do more with less. So with this, we have come to the end of this webinar. If you have any questions, please feel free to use the questions tab to your right to send your questions in. I'll be more than happy to answer them. Okay. We have a question here. How do you choose between the two approaches to HSM implementation? Okay, it's a good question. For the benefit of everyone, let me quickly move to the slide that talks about the two approaches. So, in approach 1, the private key resides inside AppViewX, and in approach 2, the private key resides inside the hardware security module. So, how do you choose between the two? It's very simple. Some devices require the inclusion or bundling of the private key with the certificate, which is only possible in approach 1 as the private key resides inside AppViewer. But in approach 2, the private key cannot be retrieved from the hardware security module and hence cannot be pushed to any device. But certain devices, such as an ADC, or to be more specific, an S5, can use the private key reference in approach 2 to read the private key content from the HSM device without ever needing to retrieve the private key from the HSM. Thus, if your device is connected to an HSM and access the private key inside using the private key reference, use approach 2 or else use approach 1. If you're confused between what to use when, we are providing both the approaches as standard and you will choose between both the approaches on the slide. Hope that answers your query. We have another question here. You're storing the private keys in your database. What if they get compromised? So that's a very good question. So if you're going to invest any money in us and if we are not able to help you secure your private keys, and that's actually a problem. So first, by assuming that we're storing the private keys in our database, we have implemented approach 1 of our integration. This means that the private key has been encrypted by the data encryption key, which has been encrypted by the key encryption key, and which in turn has been encrypted by the master encryption key residing inside the HSM. On top of this, the encrypted private key resides inside an AES 256-bit encrypted database, which makes it almost impossible for the hacker to extract the original private key content. So in a nutshell, your private keys are very secure with AppViewX. Hope that answers your question. In the interest of time, I'll be answering the remaining questions personally via email. For any feedback or comments on this webinar, you can contact me at janish@appvux.com. That is JANEESH@appvux.com. And for any information on our other products, please visit www.appvux.com or mail your queries to info@appvux.com and we'll be happy to help you. Thank you for joining us today and have a great day ahead.